All right, what are we doing today? Solving systems of equations. Haven't we already done this? Why are we doing it again? No, there's not a new way.
Different equations?
Different equations, right? What kind of equations did we do last time? Lines, right? We did linear equations. We did systems of linear equations, right? What have we done since then? Parabolas, right? We've done quadratics. And are there other kinds of equations that we can graph? Yes, we could have solutions. So first of all, remind me, when we're doing a system of equations, God bless you, when we're doing a system of equations, where are the solutions? Where they cross, right? Where they intersect, okay? So when we did systems of linear equations, like there's one equation, there's another equation, and where was the solution? Right there, right? What was the other another possibility? Here's one equation. Here's one equation. How many solutions? So I'm going to write one solution. How many solutions were there? No solutions. And what was the other possibility? Here's one of the equations. There's the other one. How many solutions is that? Infinitely many possibilities, right? So what happens when we add a parabola into the mix? How many possible solutions do you think we can get? How would we get one? So what do you mean to draw to show one solution? A parabola, okay, there's a parabola. Now what? You want a tangent line? Isn't that one solution? Isn't that the definition of tangent? Right? Okay, so that's one solution. Is that the only way we can get one solution? I'll give you a hint. I'm drawing 4 more graphs. What if I did 2 parabolas? Could I get one solution with 2 parabolas? What about that? Isn't that one solution? Right there? What if I did one parabola up here and one parabola right there, where they touch right at the vertex? Isn't that one solution? And there's tons of ways I can get, well, I say tons. There's a parabola. What if I had just a vertical line? Isn't that one solution right there? One solution. And if I had a parabola and a vertical line right there at the vertex, isn't that one solution? Now that's kind of like a tangent line. It just happens to be a horizontal line. I said vertical, I meant horizontal, right? So is one solution the only possibility? What else is a possibility then? 2, okay. How am I going to get 2 solutions? Oh, okay, so a parabola right here and a line like right there. Is that 2 solutions? 1, 2. 2 solutions. How else? A parabola and another parabola, like that. How many solutions is that? 1 right there, 1 right there. 2 solutions. So is all we can get 1 solution and 2 solutions? What else can I get? Infinitely many solutions. So there's a parabola, and where's the other parabola? That's close, right? You can use your imagination. Infinitely many solutions. So infinitely many, 1 and 2. That's all I can get? No solution? How would a no solution look? What about parabola here and Like that. That's no solution, right? What about what about a parabola here, like a real wide parabola, and then a real narrow parabola right here? Is this going to get wide enough to get out to this other parabola? No. So that's no solution as well, right? What if I had a parabola? Let's see. I want you to figure that one out. No solution, one solutions, two solutions, infinitely many. Is that the only options? Can I get 3? How? How can I get 3 solutions? How can I get 3?
What if you started at the vertex and then went like up? So there's only 2 things.
Like that?
Yeah.
Well, for it to be a parabola, it's got to curve. And if it curves, it's not going to go back out.
What if it curves? I don't know.
So think outside the box a little bit for me.
Horizontal parabola.
Absolutely. Isn't that 3 right there? 1, 2, 3. 3 solutions. Very good. So can I have 4?
Wow.
Yes? Where's the other one? It just goes further, okay? Like that. So 1, 2, 3, 4. 4 solutions. Any other way I can get 4 solutions? Again, thinking outside the box. Watch. Well, that's an ellipse. If it was a circle, I would be a terrible circle drawer. And for the record, I usually am a terrible circle drawer, but I wasn't even trying to draw a circle there. I was just trying to draw an ellipse, which is another shape, just like a flat circle, like an oval, right? But there's 4 solutions there, right? 1, 2, 3, 4. But if I drew a circle, could I also have 4 solutions with a circle? Yes. Okay. All right, I'll be brave. I'll start with the circle. Yes, that's usually how my circles look. What if I did this? Like that. So 1, 2, 3, 4. 4 solutions. So can I have 5?
Yes. Yeah.
Okay, what am I drawing? A circle? Again with the circle, huh? You're just trying to make my life easier, harder today. That's circle-ish, right? Okay. So where's the what else you meant to draw? A parabola? Okay, so how am I going to draw a parabola so I get 5 solutions? Tell me. You're good.
The parabola on a square where it follows the line, but then it goes through it. It curves with it, but it keeps going. Right? When that works, you get 50 solutions. Like a billion solutions. I don't know.
50 solutions?
Yeah, just because you follow the curvature of the circle, but it keeps getting bigger for a little bit.
So the definition of a circle is that every point on that circle is equidistant from the center, right? Mm-hmm. If it's a parabola, it will never exactly follow the circle because of the definition of a parabola. So I can do like this and scoot it up. If I scoot it up a little bit, if I scoot this parabola up a little bit so it's just touching that one place, But if it's only touching one place, that's going to be 1, 2, 3 solutions, not 5.
All right.
Or 50 or whatever you said. Good thinking, but we have to remember our definitions, right?
Yeah.
Okay? So can we have 5 solutions? I'll tell you this, if you figure out a way, I would love to see it, because I don't know it either. Okay? I don't know how to get 5, if there's a way. I know I kind of threw in the circle and the oval at the end, right? Because we haven't really talked about that, but that's because you've been through geometry, that's something you're supposed to already know and stuff. Right? But that's okay, right? Any questions about this? So if we have nonlinear, now, are there other things I could graph that would create more solutions? Yes, absolutely. If I want to create like a sine curve or a cosine curve or something like that, that's one of those that goes like this. It's like like that. I could have a whole bunch that way, right? I could have a whole bunch of solutions that way. But if we're talking about like circles or ellipses, like ovals like this, or lines or parabolas, pretty much 4 is what I can get, right? Okay? Are you okay so far? So how did we talk about graphing? How did we talk about solving these? How about if I tell you the answer when I'm asking the question? How did we talk about solving these? I just told you the answer. Oh, graphing, right? Graphing, okay. Yeah. So, what if I want to solve y equals negative x plus 4 and y equals negative x squared plus 4. So I'm going to graph this first one with red, just so you know. How do I graph this line? What do I plot first? Y-intercept, so 1, 2, 3, 4. And then what's my slope? Negative 1, so down 1, right 1. I'll go ahead and make all the dots that I can so I can see the whole line really nice. I can also go up 1 and left 1. Now how do I graph this parabola? I'm going to graph it with blue. This is in vertex form, isn't it?
Yeah.
So I can just take the regular parabola and go up 4, right? 1, 2, 3, 4. And then there's no multiplier in front of the x squared, so I know its parent function shape. So 1, 1, 2, 4, 3, 9. I'll explain that in a minute just to remind you. But I also know it is what? Upside down, right? So over 1, down 1, over 2, down 4. Why is it over 2, down 4? Because 2 squared is 4. And so over 3, down 9, because 3 squared is 9, right? And I can do that because there's no multiplier in the front. Do you remember that? It's been a couple weeks since we talked about that, so just reminding you. Okay? I also know parabolas are symmetric. Now I could go over 4, couldn't I? If I went over 4, how far down would I go? And why is it 16? 4 squared is 16, right? So 4... 16. So how many solutions do I have? I have one right there. and one right there, right? I have a solution at 0, 4, and I have a solution at 1, 3. And how did I find those solutions? Yeah, I looked with my eyeballs, right? Where did these two cross each other? Right there and right there. Now, in the parabola, it's not a straight line between those 2 points, is it? It goes up and then back down. It's very slight, but it does that, right? Okay? So that's how we solve by graphing. Can I solve by graphing using my calculator? Yes, absolutely. But if it says solve by graphing, I am asking you to do it on graph paper. So can we just sketch a quick graph of this, or do we need exact points? Exact points, right? And if for some reason I suddenly forgot how to graph a line, are we okay going into putting it in the calculator and looking at the table? Yeah, that makes me cringe. That's ick for me. That's an ick, right? Because you got to know how to graph a line, okay? You got to know how to graph the parabola. If you need to use your calculator to help you out, okay. Use it to check for sure, right? Use it to check for sure. But I really need you guys to know how to graph these two things, right? We spent quite a lot of time. We spent like all of Algebra 1 learning how to graph lines, right? And working on it. And then you spent some time in Algebra 1 graphing parabolas. And now we have already done both of these things in Algebra 2. So hopefully you're good at it. Not judging if you're not, right? Because I'll help you if you need help, right? But hopefully you're to a point where you can graph both of those already. Okay? All right. So that's one of the ways that you need to know how to solve a system of nonlinear equations. What's another way that we talked about last time? Do you remember there were 4 ways that we talked about solving systems of equations last time? That's quadratics, but good guess. Who did their foldable over solving systems of equations? Anyone in here? So what ways were there? Graphing was one. Substitution was one. Elimination was one. Matrix was one, right? Now, much to your sadness, we cannot use a matrix. Okay? We cannot use a matrix to solve a system of nonlinear equations. All right? So elimination and substitution we need to talk about real quick. Okay? I'm just going to scoot this down and use the side paper. There's no reason to waste it, right? You can write it on your notebook paper that you have out if you want. But let's talk about this one first. Y equals negative x squared minus 6x minus 10. And y equals 3x squared plus 18x plus 22. If I want to solve this system of equations by substitution, how do I do that? How do I solve by substitution? Because substitution implies what? We're putting something in the place of something else, right? So if this equals y and this equals y, can't I put this right here, right there, in for y? Yes? Okay. So 3x squared plus 18x plus 22 equals negative x squared minus 6x minus 10. So what do I do now? If it's a quadratic, what do I want it to equal? 0. How am I going to get this equal to 0? Oops. Add x squared. Add 6x. Add 10. Because what does this equal on the right hand side now? That's 0, that's 0, that's 0. So it equals 0 on the right hand side, right? On the left hand side I have 4x squared. Then what? 24x plus 32. Right? So how do you want to solve this? Oh, you want to take out a 4 first? Is that a good idea? Yes, so if I factor out a 4 first, let's divide both sides by 4. What do I have left on the left-hand side? X squared plus 6x plus 8. How do you want to solve this? We have all the ways that we know to solve quadratics now, right?
The song version.
You want to do quadratic formula? Okay. So here's A, here's B, and here's C. X equals negative B plus or minus the square root B squared minus 4AC all over 2A. Negative 6 plus or minus the square root of, let's see, 4 times 1 times 8 is 32. What's 36 minus 32? 4? Oh, that's nice. Because now we get x equals negative 6 plus or minus 2 over 2. What is negative 6 plus 2? Negative 4 divided by 2? Negative 2. What's negative 6 minus 2? Negative 8 divided by 2? Negative 4. So what did I just find? Is this my solution? The x values. So what do I know? How many solutions do I have? 2. I have 2 solutions, right? One of the solutions looks like negative 2 something, and one of my solutions looks like negative 4 something. How do I figure out the somethings? Because see, remember I solved for x. I have 2 x values. That means I have 2 solutions, and those are the x values for both of the solutions. How do I find the y values of my solutions? Yeah, go back to the beginning, right? Do you want to use top equation or bottom equation? Top, right? Numbers are smaller. Okay, so negative 2 squared is 4, but then I have negative 4 because of the negative. Negative 2 times negative 6, that's plus 12, and then minus 10. So negative 4 plus 12 is 8, and 8 minus 10 is negative 2. So when x is negative 2, y is negative 2. Now I got to start again and use negative 4 this time. What's negative 4 squared? 16, but then I have a negative 16 because there's negative was already there. And then I have negative 6 times negative 4, so plus 24 plus 22. So I have negative 16 plus 24. What's that? Eight. It's 8. I'm just trying to figure out what I did because I know the answer and I'm not getting the answer.
Where's 22 come from?
What? If I plug negative 4 in right here, negative 4 squared is 16, then I have negative 16. Negative 4 times negative 6 is plus 24. Oh, I don't know. I was looking at the bottom. Thank you. And then minus 10. So I have, again, 8 minus 10. So negative 2 again. Will it always be that way? Will they always both be negative 2? No, it just happened to be on this example, right? So any questions about substitution? All right, then let's do one more example, but this time we're going to do elimination. Okay? But to help us out, we're going to do this problem again. Why would we do the same problem again? We know we're going to get the same answer, right? Now, when we solve by elimination, what are we trying to do? Yeah, we're trying to eliminate a variable. That's why it's called elimination, right? So, normally what we did was we figured out which variable should we try to eliminate. It was either x or y, right? Guys, when there's x squareds involved, should we ever try to eliminate the x's? No, we can't. Well, I guess we can. Sometimes it's easy, but most of the time it's not. Because what can I multiply? In this case, it would be, right? If I multiply the top, everything in the top by 3, wouldn't both of these eliminate? Most of the time it won't, though. I'll tell you that right now. Most of the time it won't. Okay? So most of the time you're going to want to eliminate the y's. What do I need to multiply the first equation by to eliminate the y's? How about a -1? I'm going to write it right underneath. Negative y equals x squared plus 6x plus 10. Now in elimination, remember we're adding these two equations up. So what's y and negative y? 0. What's 3x squared and x squared? 4x squared. What's 18x and 6x? 24x. And what's 22 and 10? 32. That seems familiar. Oh, look. But I do want to show you something different this time. Let's divide everything by 4, just like we did last time. When I divide everything by 4, I get 0 equals x squared plus 6x plus 8. What if this time, instead of doing quadratic formula, we factored? Since the leading coefficient is 1, what two numbers multiply to be 8 and add to be 6? 2 and 4. What do I do with these two factors? I set them equal to 0, right? If I subtract 2 from both sides and subtract 4 from both sides over here, I get x equals -2 and x equals -4. Now isn't that what I got over here? -2 and -4? Once again, that's telling me there's two solutions, and one of them looks like -2 something, and one of them looks like -4 something. And how do I find out what those somethings are? Plug them back into one of these top equations. Now I know I'm going to get -2 both times, right? Because I've already done this and I already know what the answers are. But does that make sense in how to solve with elimination? Do you have any questions? So when I graph, when I solve a system of equations by graphing, what am I looking for? The point or points of intersection, right? If I'm solving with substitution, what am I looking for? The point or points of intersection. If I'm solving by elimination, what am I looking for? The point or points of intersection. Okay, does that make sense? Do you have any questions about this?